So traditionally, as an atmospheric chemist, I would study compounds that exist in the gas phase in the atmosphere. But in more recent years, there's been an emerging field called aerosol chemistry, or the study of atmospheric particulate matter. Now, this particulate matter is just simply small solid and liquid droplets that are suspended in the atmosphere. But these small droplets have huge implications, not only for public health and air quality, but these particles are the single greatest contributor to the uncertainty in how humans affect climate change. Now, these particles can absorb and scatter light, but they can also seed the formation of clouds in the atmosphere. Now, overall, this has a net cooling effect, but the extent of this effect is basically unknown. In order for us to quantify how these particles affect climate change, we have to determine their properties. And there's two basic properties we can determine. First, their size. And atmospheric physicists have done remarkable work in being able to size these particles. We actually have an instrument that can collect and separate particles from 10 microns, which is just larger than a red blood cell, down to 10 nanometers, which is only a few molecules wide, into 13 different size bins. By understanding the size of these particles, we can determine how well they'll scatter light, how long they'll live in the atmosphere, and how far they'll travel. Furthermore, particles below 2.5 microns in diameter, when we take a deep breath, just like Nathan said, will pass right through our lungs and directly into our blood. So just from a toxicology standpoint, it's important to understand property number 2, which is the composition of the particles. Now, this has been done to an extent, but as of yet, only the inorganic fraction has been determined in the particles, or the salts present. The organic fraction, by and large, is unknown. So because chemical structure can vastly influence chemical property, it is my job to speciate, or to determine the individual compounds present in that organic fraction. Once we can relate the components that are present to the bulk property of the particles, we can then determine how well they'll absorb light, how well they will make those clouds in the atmosphere, where those particles came from, and even how big they'll grow. Once we can determine how the composition relates to the particle and its properties, we can determine not only its toxicological effects and air quality effects, but we can actually quantify and significantly reduce the uncertainty in how humans affect the global climate. Thank you.